Hi guys, welcome. Unfortunately, I will not be able to be in tutoring this evening, so what I decided to do instead was videotape myself going over these lessons with you. That way we had access to them, so that when we're working on 4-5, which is what I'm going to have you guys work on after this, you'll have a lot more knowledge about this. You'll have a video to refer back to. This will be a good video to use between class time tomorrow when I'm absent, as well as for extra practice for you guys. So we're going to go into this and go over some problems that are going to be on 4-5 that I really think are going to be ones that you will need to know. This will also be a good time for you to get a little bit of extra assistance from me. You're more than welcome to send messages to me while I'm out. I may not answer them based on being at the doctor and everything, so we'll just kind of jump into that and talk about the things that we're going to do. So we've been working in algebra extensively this past unit. And one of the things that trips us up is actually combining algebraic equations with decimals and with fractions. So today that's what we're going to focus on. We're going to talk about those things. I'm going to give you an example of each, and then I just want you to try it and see what your score is going to be. When I return on Friday, I'll be pulling people based on those scores. Okay? So we're going to have a problem that looks like W minus 3.4 equals 5.1. Okay? I'm hoping that shows up. Let me just double check really quickly that it's there. Oh, it's a little bit too tall, so let me go ahead and move that down. I'll make sure that I write below this line from now. All right, W minus 3.4 equals 5.1. Okay? When I have W minus 3.4 equals 5.1, I need to ask myself, what is my first step in solving an algebraic equation? So what's the first step in solving an algebraic equation? I feel like Dora the Explorer. I'm kind of giving you a little bit of time to answer that. You're right. It is actually going to be to isolate the variable. So we isolate this variable, that W, and how do we do that? What do we have to do to isolate that variable? You're so smart. We have to do the inverse operation right there. So the inverse operation of this is going to be the opposite of whatever our operation is that we're doing. What are we doing to this W currently? We are minusing 3.4 away from it. The inverse of that is addition. The inverse of negative is positive. The inverse of subtraction is addition. Okay? To make the equation true, whatever you do to one side, you must also do to the other side. Okay? So we have to add, thank you Lucy by the way for these markers, 3.4 to both sides. Okay? We have to add 3.4 to both sides. Now, those of you that have gone over this with me, you know that when you have an inverse operation there, a negative 3.4 and then a positive 3.4, they cancel each other out, so that all you're left with on this side is a W. Okay? When you add those together, pretty simple. That W would equal 8.5. Okay? If this doesn't make sense to you, ladies and gentlemen, please, please, please ask for help. Okay? So that is the simplest thing there. The easiest equations are honestly using decimals and adding and subtracting them. Okay? If this was addition here, if this was an addition problem, so let's just say that we did this as adding 3.1 equals 5.4. I know I changed those numbers up. I did that purposely. Okay, this used to be 3.4. That's now 3.1. Same thing. It's the opposite. So whatever you do, your whole goal is to isolate this W. Okay? To do so, you're going to subtract. In that case, subtracting it from that positive means that the only thing that's left over here is W. Cancel culture, we've gotten this part canceled out. Okay? And when you do that, you would get 2.3 in there. Okay? So the inverse operation is the opposite operation to whatever it is you are doing to that W from the first time. Cool? All right. Let's go forward here, and I'm actually going to use an eraser because my hand's getting pretty messy. So I'm going to say this. If addition and subtraction are tripping you up with decimals when you go back in and are doing this assignment, go back and rewatch this first part of the video, okay? Pay attention to the steps that I do. Watch it in a slower speed if you need to. But I really think that adding and subtracting decimals is pretty easy for us, okay? Cool? Talk about when it's not so easy then. So say that we have a number like 4.5 equals 1.5x, okay? This is not an addition or subtraction problem, so it must be a multiplication or division problem. So let's look here. 4.5 is by itself. There's obviously nothing happening to that. 1.5x. So I'm asking myself, and maybe you already know this, when I have a number directly next to a variable, what operation does that show? When a number is directly next to a variable, what operation does that show? I think you got it. That's multiplication, right? When you have a number directly next to a variable, that's multiplication. So to solve this problem here, we have to isolate that variable. I'm kind of trying to do the Dora the Explorer thing. We'll see how funny it is. Isolate this variable, ladies and gentlemen. Okay? You isolate that x. How are you going to do that when you're doing a multiplication by decimals problem? Well, the opposite of multiplication is division. So to cancel these out, we need to divide. Whatever you do to one side, you must also do to the other side. Okay? Cancel culture cancels that out. What are you left with on that side? You're left with an x. Okay? On this side, we rewrite this problem. Okay? 4.5 divided by 1.5 equals x. So how do we go about solving this problem? Well, this right here, if you remember, this 4.5, this is called your dividend. Okay? Sorry, this is not called your dividend. Trip me up because it's on the opposite side of the equation. This is your divisor. Your divisor, excuse me. Your divisor is the number that is being divided there. Okay? And then this 1.5, this is your dividend. Okay? So what do you do to solve this problem now? Well, when you have a dividend that has a decimal, you cannot divide by a decimal. Okay? You have to make that decimal into a whole number. So you have to turn your dividend into a whole number by moving the decimal point all the way over to the right of the numbers. What that means is this, okay? Divisor, dividend, okay? 4.5 divided by 1.5. I'm going to switch colors so that this is easier to see. With your dividend, you have to move that decimal point over one place value, okay? Doing so, that makes this number 15. And because we only moved it over one place value here, we'll determine what we have to do next. The second step of a dividing by decimals equation is however many place values you move the decimal point over in your dividend, you must also move the decimal point over in your divisor. So we move this over one place value. We need to move the opposite side over, or the divisor over, another one place value. That makes that 4.5 equal to 45. So now we have a problem that is 45 divided by 15 equals x. Okay? Now all you have to do is simply solve the new problem. You don't have to worry about moving anything over. We just solve this new problem. Okay? So 45 divided by 15. All right? I know the answer because I'm pretty good with my facts, but I'm just going to go through this if we don't. We're going to start off here writing our multiples of 15. 15 plus 15, that is 15 times 1 and 15 times 2. 15 times 2 is 30. Not quite there yet. Times 3 plus 15, and I get 45. Now, it doesn't make any sense for me to have to go back through and do all of this work all the way up to 5 when I already know the answer. 45 divided by 15 is 3. 3 times 15, 45. Boom. So my answer in this case, ladies and gentlemen, 4.5 divided by 15 equals x. The answer is 3. Okay? And that is how you divide by decimals. We've done that several times this year. I'm going to also post a picture of all of our signs online so that you guys have access to them. Okay? But when dividing by decimals, get your dividend by itself as a whole number. Whatever you did to make that a whole number, you must also do to your divisor. Okay? Solving that problem, it's division at this point. Okay? Cool? All right, that is dividing by decimals. That is a multiplication algebraic expression where you have to do the inverse of division when it comes to decimals. Okay? Wonderful. Let's go forward a little bit more here. What happens when you have a number like y divided by 3.12 equals 1.5? Now in this case, you have a division problem when it comes to algebra. So how do you solve this division problem in algebra? So you have y divided by 3.12 equals 1.5. Your whole goal to start this off is to isolate that variable. You have to isolate that y, okay? In this case, to do so, you do the opposite operation, the inverse operation of this. Since this is division, the opposite is multiplication. You're going to multiply both those by 3.12. Whatever you do to one side of the equation, you must do to the other side of the equation to make it an equivalent equation, okay? Cancel culture cancels those out. We're left with y. And I'm going to rewrite this problem as y equals 1.5 times 3.12. Okay? We are now multiplying by decimals, ladies and gentlemen, and I really feel like we're more comfortable multiplying by decimals than we are dividing by decimals. Okay? Just going to check one thing really quickly. Make sure that I have this. Hoping that my other problem was easily viewed. I think it was. It's close. Okay? But I'm just going to check and just make sure. All right. Now we have to go into how to multiply by decimals here. Okay? When you multiply by decimals, there's a few rules that you have to follow. First step is you must count your decimal places in here because that's going to tell you how many total decimal places you're going to have in your actual number. So let's count here. We have 1 right there until we get to the end, and we have 1, 2 over here. That tells us that we have a total of 3 decimal places, ladies and gentlemen. Okay? We have a total of 3 decimal places in our number. Okay? So we've counted the decimal places. We're now going to rewrite this problem without decimals. Because we know how many decimal places are going to be in our answer, we rewrite this problem without decimals. Now, we go about solving this problem. We're going to solve 312 times 15. I know it was 15 times 312, but I like to reverse that, and I like to start with that higher number first. Okay, because it's easier for me to multiply by 2 numbers than it is to multiply 2 numbers by 3 numbers. Okay, makes it make sense lining it up. All right, first step here. Those of you that have been with my tutoring, you should already know. We're going to start in our ones place here. We're going to take this 5 and we're going to multiply it by all 3 of those top numbers. So 5 times 2 is going to be 10. Take that 1 up to the top of that tens place. 5 times 1 10 is 5 plus 1 is 6 tens. I call that 6 tens because that's in the tens place there. 5 times 3 now is 15. Okay? I am now officially finished with my ones place. So I'm going to move on to my tens place. Multiplying by a 10, that tells me I need to add a 0 at the end to start. 1 times 2, 2. 1 times 1 in the tens place is 1, and 1 times 3 is 3. I'm now going to add all of those numbers together. To get my grand total answer as 4,680. I started correcting myself before I went through. That is 312 times 15, but our original problem was 1.5 times 3.12. We have 3 decimal places, so we go back in and we bring them in. We go 1, 2, 3. Our answer, y equals 4.680. So to make sure that we have these answers in there with multiplication of decimals, you need to count your decimal places before you do anything, okay? Count the total decimal places, multiply each one. Don't forget that when you're multiplying by 2 numbers, you have 2 lines of text there. Once you've found that answer, bring back in your 3 or your decimal places there. Put your decimal in the correct position. We're good to go. Okay? That is a division of algebra, or an algebraic division equation. To solve it, you must use multiplication. Okay? Cool? All right, I think we're good with decimals. I think we've gone over every single decimal example here. Let's jump into ones that are not as friendly for us, some that are a little bit more challenging. Okay? Let's jump into some fractions. We're going to go over a few of these, and then I'm just going to let it be what it's going to be. All right? So we have 2 and 3/4. Let me move that down because I feel like I'm getting a little bit too tall. 2 and 3/4 plus m equals 6 and 1/9. Okay? What is the first step when we are solving algebra in anything that we do? I'm hoping that you're able to tell me that it is going to be isolating this variable. Well, how are we going to isolate this variable right here? This plus sign tells me something, but since there's no sign out front of this 2 and 3/4, we know that that's a positive 2 and 3/4. In order to isolate that positive, or that m, we have to get rid of that 2 and 3/4. To get rid of that, we must subtract 2 and 3/4 from that side. We do it to this side, we must also do it to the opposite side, ladies and gentlemen. Okay? Doing both of those cancels that out. We're left with m on this side. M is equal to 6 and 1/9 minus 2 and 3/4. Oof. You should know, by the way, that 1/9, you cannot take 3/4 away from it because they do not have they do not have the same exact, they do not have the same denominators. You can only add and subtract with different denominators, okay? So, let's go ahead and split this apart. This is 6 plus 1/9 minus 2 plus 3/4. Let's isolate the things that we know we have to change so that we can actually subtract them. Okay? Over off to the side over here, I'm going to go ahead and take note that I'm taking this 1/9 minus 3/4. Okay? And this is where cross multiplication comes in. This will be the last one that I actually do today, guys, just based on time. I'm looking at the clock, and I have to get back to you guys actually over here. So let me just make sure that that 1/9 and 3/4 is on the screen. Beautiful, beautiful. So I'm isolating those because I know that I have to subtract fractions here, and I know that I cannot do so. So what I have to do is actually use the butterfly method, like some of you would call it, but really cross multiplication, because my first step here is I have to be able to get both of these to have the same denominator. To do so, I'm just going to start off multiplying both those sides to get the same denominator on each. So in this case, 9 times 4 is 36. So this actually equals 36, 36. Both of those have now identical denominators. Okay? Now, for cross multiplication to work, whatever I multiplied that 9 by, I must also multiply my top number by. That's how this works. But how it actually looks is I cross over. And I'm going to multiply that 1 times 4 to get to 4 right there. Okay? So I'm trying to now subtract, so I'm not trying to subtract now. I'm changing this 1/9 into 4/36 because that's an equivalent fraction of it. Okay? I multiplied that 9 times 4 to get 36. Whatever I did to that 9, I must also do to that 1 to get an equivalent fraction. That's why we get 4/36. Okay? I do the same thing on the opposite side. I start with the numerator and I work myself down to the denominator. 3 times 9 now, which is 27. Okay? Same reason. I got from 4 to 36 by multiplying by 9. Whatever I did to the denominator, I must also do to the numerator. That's how it looks, but that's how it works. Okay? Now we have a problem. We can't take 4/36 and we can't subtract 27/36 from it. So what do we have to do? I'm going to rewrite this problem now as m equals 6 and 4/36 minus 2 and 27/36. Okay? Some of you are already knowing what you have to do here. We have to decompose this 6 down. Okay? This 6 can be decomposed down into 5 plus 1, which would then be 5 plus 1 plus 4 and 36. Would you agree that that equals 6 and 4/36? Okay, good. So what do you do from here? Well, we're going to leave this 5 alone, okay? We're going to bring this back down and say that that's 5, but then let's break this 1 down into a whole. So a whole number out of 36. So how many 36 would it take to make one whole? It would take 36 plus 4/36. So now we're going to take all this information, and we're going to rewrite this as a problem. 5 plus 36 plus 4/36 is going to be 5. 36 plus 4 is 40/36. The reason that we're getting 40/36, we broke apart that 6 into 5 plus 1, broke apart that 1 right here into a whole, which is 36/36, so that we can add that 4/36. So we have 5 and 40/36 minus 2 and 27/36. Okay? If you're confused, pause the video, rewind, figure out how I got to 40/36. Okay? Now it's simply combining like things. We're going to combine our fractions. We're going to combine our whole numbers. We have to subtract 40 minus 27. We're keeping the 36 because it's saying that that's our denominator. We never change our denominator. Okay? 40 minus 27 looks a whole lot like 13 to me. 5 minus 2 looks a whole lot like 3. So, in this case, m is going to equal 3 and 13/36. Now, I know that this is a long, drawn-out problem. I know that it's hard, but it's not impossible. We can do it, okay? So, I want you to try it. I want to see what you can do, okay? On your own, I want to see how you can solve these problems. So, do me a favor. If you still need help on some of these, go back and rewatch parts of this video that you need. But I want you to jump in, and I want you to try 4-5 on your own, okay? All right, I believe in you guys. Use your question helps if you need it, but at the same time, go at it and attack everything that's there. All right, thanks.